lastly, if we take a look at BD, say BD is also a chord, and BD is subtending C at the circumference. So you realize that all these angles are subtended at the circumference. Chord CD is subtending B at the circumference. Chord CB is subtending D at the circumference. And chord BD is subtending C at the circumference. So angles are subtended at two places in a circle. One at the center, two at the circumference. Now, what I'm going to do is that I'm going to draw a diagram on the board for you, and then you are going to tell me the angles subtended at the center and the angles that are subtended at the circumference. So if you see 10 angles subtended at the center, you write all of them down for me. Angle O is subtended at the center by chord so and so. Angle K is subtended at the circumference by chord so and so. In that manner. So I'll give you just 1 minute for you to do that exercise for me. Make sure you follow all the steps that I've given to you. 1, remember I explained that we use only chords to subtend angles. I have forgotten the arc for now, so I'm only focusing on the chord. So we use chords to subtend angles, and the angles will be subtended at two places. 1 at the center and 2 at the circumference. So your focus should be on the chords. Which one is the chord? Which angle is the chord subtending? And where is it subtended? Is it at the center? Is it at the circumference? So I'll give you one question, and good luck to you. In a minute's time, I'll come around and then I'll see if you had the same solution or the same answers that I had. So I have already drawn the circle for you. So there's the diagram. So write down the angles that are subtended at the center and the angles that are subtended at the circumference, and by which chords. So chord so and so subtends angle so and so at the center, or it subtends angle so and so at the circumference. So you have a minute, and after that I will come for the answers. Good luck to you. Start work. Okay, now let's check if you were able to get the answers that I'm going to display on the board for you. Alright, so we have already explained that we use chords and arcs to subtend angles. So first of all, my focus is going to be on the chords in this diagram. I'm going to look out for the chords. Now, we say chord, or a chord will join 2 points on a circle. So if you check this, I have point P and this I have point Q. The line joining point P and point Q is a chord. So this line here is a chord. So it means that that chord can subtend an angle. 1 at the center, 2 at the circumference. I'll look at the chord, also QR. Why am I saying QR is a chord? Because Q is a point on the circumference, R is a point on the circumference, and we have a line joining the point Q and the point R. So QR is also called a chord. And the same goes for PR. PR are 2 points on the circle joined by a straight line. So this line here, the line PR, is also a chord. So I will consider the line PR, consider the line PQ, and consider the line QR. Now, I will not consider the line OP. Why? because OP here is a radius. And I didn't mention that we use radius to subtend angles. I said we use chord. So it means that this OP here, I will not consider the OP. The same way OQ. So I can't use OQ to subtend an angle. I can't use OP to subtend. So we use 3 lines here. We have 3 lines. So we can use PQ, we can use PR, and we can use RQ or QR. So I'll take those chords one after the other and look at the angles that is subtend. Now remember, if the chord is subtending an angle, it should have a connection with the lines which create the angle. So this is P and this is Q. Now, if I look at PQ, I will follow the lines that are standing on the chord PQ, or the angle that has 8 lines standing on the line PQ. So I'll follow the lines. So you realize that the angle O is standing on chord PQ. How do I know that? Look at the 2 lines. 1, 2. These 2 lines create the angle O. This line stands at a point P, or this one has a connection with the line point P, and this one also has a connection with a point Q. So PQ here is subtending angle O. You realize that angle O is the angle at the center. So PQ subtends angle O at the center. So 1, I will say chord PQ subtends angle either POQ or QOP. So subtends angle POQ at the center. Two. Now, if you notice chord PQ very well, it has more than 2 lines there. There are more than 2 lines there. Now, PQ is subtending O at the center. Look, there is another line here. Look at this. And that one also has a connection with P and also with Q. So I'll trace the 2 lines. So you realize that PQ is also subtending angle R, but R is at the circumference. So PQ subtends angle R at the circumference. So let's follow. If I follow these lines, you realize it's subtending R. If you look at the 2 lines which creates angle R, you realize one line has a connection with point P, and the other line has a connection with a point Q. So we say PQ subtends angle R at the circumference. So 2, chord PQ subtends angle PRQ. Angle PRQ, this time around at the circumference. So chord PQ subtends angle PRQ at the circumference. Now let's look at the other chords. Remember, we have identified 3 chords. We've also identified that QR is also a chord. So let's look at the angle that QR is subtending. If it's subtend the angle, the lines which create the angle should have a connection with the chord. So let's look at QR. Realize that this line has a connection with Q, and this line has a connection with R. So I will trace to check which angle QR is subtending. So I'll follow the two lines, and you realize that QR is subtending angle P, and it's subtending P at the circumference. P is on the circumference. So QR subtends P at the circumference. So 3 chord QR subtends. Chord QR subtends angle QPR at the circumference. Four. Now we can also see we have a chord RP over here, PR, chord PR. Let's look at the angle that chord PR is subtending. If it's subtending, the lines which create an angle have to have a connection with PR. The lines which have a connection with PR is this line and this line. So I will trace PR. So PR is subtending angle Q. Q also at the circumference. Q is also at the circumference. So 4, we say chord PR subtends angle PQR at the circumference. At the circumference. Now, we did also make a note from the beginning, which I also like to add to these ones. So let me make that 5. Now, you remember that we also explained that OP here is a radius. OP is a radius, and OQ is also radius, because the definition for radius states that it is a straight line from the center to any point on the circumference. So from the center O to the point Q, this line here, radius, and from the center O to the point P, this line is also radius. And the radius is always equal, or they will always be equal in length. So the line OP will be equal to the line OQ. So if this line OP is equal to the line OQ, then we said that will make triangle POQ isosceles. Because an isosceles triangle is a triangle in which 2 of the lengths are equal. So if we combine these 3 points together, point P, point Q, and point O, you realize that point P, Q, O forms a triangle. This one, P, Q, and O. And this triangle becomes isosceles triangle because this length and this length are equal. And if the 2 lengths are equal, then the base angles are also equal. So that if this angle is Y, then this angle is also Y. We establish that. So always the triangle formed here is an isosceles triangle because of the 2 lengths being equal. Because OP is a radius and OQ is another radius, the 2 radii will be equal in length. So this length is equal to that, and that will make the triangle here isosceles, so that the base angles here will always be equal. If this is 10, it means this side will be 10. If this angle is 50, this angle is also going to be 50 degrees. On that note, the basic things you need to know under circuit theorem has been given to you or has been explained to you. We now have to move on to look at the theorems now. I'm going to give you 9 theorems, 9 of them, which all of you must learn and recite them off it. In these times of corona, I can still come to your house and ask you for the theorems. I can come to you with cane and say, theorem 1, if you can't answer, I'll lash you in front of your parents. That was just by the way. But let's make sure we learn all the theorems. I'm going to give you 9 theorems. And after each theorem, I'll give you questions to buttress the theorem. I will explain the theorems in totals, into details. I'll make sure that everything you need to know under that theorem, I'll give it to you before I move on to the next theorem. So look at it into details, then I'll move to another theorem. Then when we are done, we'll now start combining the theorems together, and I'll give you a typical WASI question. A typical WASI question will combine about 3-4 of the theorems in one question for you to solve. So, on that note, let's now look at the theorems. Now, I will not arrange the theorems in any chronological manner. They are not being arranged. What I will use as theorem 1 here, when you visit another book, it will not be the same. All that matters is the understanding. So get the understanding for yourself. It is not in any chronological manner. So I'm going to arrange them arbitrarily. I'm going to give you an arbitral arrangement, meaning that it doesn't follow any particular order. It has been, arranged haphazardly. Haphazard. Theorem 1. I'll end on the theorem, the definition with the theorem 1. In our next class, we'll now start looking at the questions related to the theorems. So I'll just explain theorem 1 to you. From our next section or our next class, we'll start looking at the questions. Now, theorem 1, it says the angle a chord or an arc subtends at the center is twice the angle it subtends at the circumference. So let me write that on the board for you. The angle a chord or an arc subtends at the center is twice the angle it subtends. Is twice the angle it subtends at the circumference. The angle a chord or an arc subtends at the center is twice the angle it subtends at the circumference. The angle a chord or an arc subtends at the center is twice the angle it subtends at the circumference. So you see that the two things we use to subtend an angle has been stated over there. It says the angle a chord or an arc subtends. But I have told you I'm only going to use the chord. So this one is out. So in your definition, you can say the angle a chord subtends at the center is twice the angle it subtends at the circumference. So what this theorem is saying is that the angle that a chord will subtend at the center. So it means, one, the chord is going to subtend an angle at the center. Then two, it says it's twice the angle it subtends at the circumference. So it means that we need a chord to subtend an angle at the center and at the same time an angle at what? The circumference. Now let's look at how to explain this definition. Now, assuming this is the center, let me call the center O. Let me introduce a chord. Now, let me call this chord A, B. Now, we all agree AB is subtending O because I've already explained this. How do I know the angle, the chord AB is subtending the angle O? We said for a chord to subtend an angle, it should have a connection with the lines which create the angle. So this angle O here is formed by this line and then this line. So you realize that these two lines which create the angle O, one line has a connection with the point A, the other line has a connection with the point B. So this AB here is holding O at the center. So AB subtends O at the center. Now I will need the same AB to subtend an angle at the circumference. So let's see. Let me call this C. Now you realize that the same chord AB here is subtending angle C. How do I know AB is subtending angle C? If I check angle C is created by two lines, this line and this line. So this line and this line creates or comes together to form the angle at C.